Good afternoon, Charles, and thank you for joining us on this lovely sunny day. Obviously got the forecast right. Um, so the Met Office, just looking at it as a business, the customers that you've got internal and external customers.
Well, the Met Office is somewhat controversially something called a trading fund. So firstly and most importantly, we are part of UK government. So we're all civil servant.
You report into DEFRA, is it, or?
To BEIS.
BEIS, okay, right, yeah.
So that was a move. We moved from the Ministry of Defence, I think, about 6 years ago, into BEIS. And so our mission is, at a very high level, our purpose is to protect life and property, to enhance well-being, and to deliver economic value to the UK. That's our top line purpose. That's why we exist. Now, when you get into the weeds of it, and I won't go there unless you ask me, but when you get into the weeds of it, that mission is hard to fulfil as a government agency that cannot participate in commercial markets. So the trading fund status does two things, really. One, it allows us to participate in commercial markets, largely to seed, innovate, and create new markets. So there are brand new markets that exist now that did not exist 10 years ago, because the ability to say something about the future environment is now skillful enough for those markets to exist. So a trivial example, well, it's not trivial, but an example would be the commercial road gritting industry. So there's an industry out there with people who hedge risk, and they go and grit Sainsbury's car park or any other supermarket's car park or whatever it might be, and obviously they need to do that in a way that minimises cost and maximises efficacy and so on. And that market is only possible because of the ability to predict not quite temperature. There's more to it than temperature. There's all manner of characteristics of tarmac and what's underneath it, and you as a geophysicist, you'll recognise this composition of what's underneath the tarmac, and all those things go into those kinds of calculations that ultimately make it realistic for an organisation like Sainsbury's to be able to keep their supermarket open because their car park's safe. So there's an example whereby there are much more impactful, but that's a nice, simple, succinct example. The other thing that it does, the ability to participate in commercial markets, is offset the cost of delivery to the taxpayer. So to some degree, we generate independent commercial revenue that allows us to make autonomous investment decisions, pay a dividend back to government, but generally offset the cost of delivery to the taxpayer.
And moving from the external customers more into the internal customers, I mean, you have different sorts of computing and different IT and different digital, if you like, and different customers. I mean, scientists are notably expert users, having been on that side myself.
Absolutely. So I'll try to say this without anybody beating me up afterwards should they ever hear it. So broadly speaking, you can talk about three characteristics of IT or computing. So the first one is supercomputing. So in that supercomputing bubble, you've got things like we have a system called SPICE, which is our research scientists' capability. That's very highly scaled, virtualized Linux, big storage, so that scientists can do effectively experiments. Take data from the HPC simulations and do experiments with them. So we've also got mass storage. So I've got a 1.2 exabytes of mass storage.
1.2 exabytes.
Big, yeah, I mean big machines. Big machines mean big storage. So all this stuff is at almost vast scale. So the supercomputers, the scientific research environment, which includes 600 Linux desktops, for example. So it's not as simple as running a simple Windows desktop thing to run Power Linux, SPICE, and the observations program. That kind of stuff all sits in bubble one, which is pretty domain specific and at vast scale. So moving on a bit, that's all very interesting, but at that stage, all we've done is produced a simulation, which is a nice science experiment, but it hasn't actually done anything to overcome our purpose. So the next bubble is what I would describe as large-scale enterprise IT. Frankly, it looks like anybody else's large-scale enterprise IT. We're on a journey like everybody is in enterprise IT. We're fairly well advanced on that journey. We don't have servers sitting under cupboards and in cupboards anymore. Everything at the very least is, if you like, virtualized on an internal cloud. Our strategy for that and for things going forward is external public cloud. So quite clearly, over time, the intention is to shift this stuff to external public cloud.
So looking at the sort of external world, what other organizations or industries do you have an impact on, or do impact on you, and you're able to, for instance, share information or benchmark against? What sort of other organizations are comparable?
Yeah, okay. So many of those comparisons fall outside of government, at least domestic government, because in domestic government terms, we're the Met Office and there's only one of us. So, so a first and important benchmark is the 190 odd organisations that do largely what we do. So they're an important source of reference. And about 5 years ago, the Met Office stood up and agreed an international benchmarking regime around IT. Because it's always better to share. So even if you're at the bottom of the list, it's good to know you're at the bottom because you know what to do. So that's been quite productive. So that's an important benchmark. Supercomputing is there are lots of people out there that do supercomputing, but outside of our domain. So we compare very carefully across the supercomputing domain. When it comes to the kind of more the second and third bubble, so the kind of enterprise IT and the apps bubble, then our comparators are industry based. So we'll be looking at financial companies, we'll be looking at retailers to get an understanding of whether our broad shape, our envelope, if you like, of operations is where it needs to be. And I'm pleased to say it very much is. I'll very happily hold my hold our performance up against anybody's. Is it optimized? No, clearly not. Generally speaking, we're absolutely unquestionably world class in bubble one. We are absolutely excellent in bubble two. When you get to bubble three is where, and this is the kind of applications end of things, is where I think we've got most to do.
Presumably, there's learning in what you're doing for the rest of government and some of the commercial sector as well, presumably.
So the way I pitch that is we are very, very deep, but we are relatively narrow. So I'm not arrogant enough, and we're not arrogant enough to pretend that we can go and do a better job elsewhere in different contexts. What we can say is we can highlight, and we do this quite regularly with some of the very largest tech companies. You can imagine the kinds of people of the implications of real scale. I'll provide an example. In the big data economy, the general approach for most organizations are to create data warehouses or data lakes, and the notion is collect enough data, collect as much data as you can, because ultimately you'll find a way to derive value and insight from those data. All perfectly plausible. The reality is that data scales are now becoming so big you can't move the stuff, never mind collect it into one place. So whilst the principle, the concept is correct, the execution will increasingly be non-deliverable. So we're helping companies understand how, as well as moving data, you can move algorithms. So that takes you to technologies like blockchain and secure containers as a way to not only move data around, but to effectively move problems around as well. So, it's a mixed economy. Right now, we tend to transmit information by transmitting data. In the future, we will transmit information by a combination of transmitting data where that makes sense, but also transferring computation or algorithms or IP, whatever the chosen phrase is. And of course, there's all kinds of problems with that. You've got to remain integrity, you need to maintain security. So that's why, things like encryption of containers come to play, being able to provide compute services where even the hypervisor can't decode what's happened. These are all areas of active research for us, and where we do, I suppose, help others understand. We provide a very tangible use case, let's put it that way sometimes.
What impact do you think the GDPR is really going to have?
I think for some organisations it will have huge impact, for sure. For others it won't. I mean, we've fortunately always had, so the minute I came here and we started interacting with the citizen at a deeper and more meaningful level, we made the decision that we did not want to source citizen data. That wasn't our role. I didn't want anything to do with it. So the amount of personal data that we hold here, our primary concern is probably around our own staff, more because we obfuscate. Well, we try not to have a reason to store stuff. Where we do have to store stuff, we obfuscate, hash, and encrypt wherever we can. And we only then store it when we know we're going to have to go back to somebody. So look, I'm not saying we're perfect, we're not, and we're undergoing a formal gap analysis at the moment. We know we have some issues. in areas like HR systems, for example, but we've provisioned for those ahead of time. So we're in the process now of pulling in software as a service, for example, to get rid of our legacy HR systems, knowing full well that buying in that way, we're going to kind of buy in compliance along the way. So we've a combination, I suppose, of planning, a little bit of foresight, and maybe a little bit of luck of making some decisions not to have that kind of stuff unless you really need it.
Looking at innovation and the futures, etc., what do you see as the big issues coming up for you in particular?
I think for us, it's abstraction. So it's learning how to be faster, better, stronger, cheaper by working in more abstract, it's the buy build thing, more abstract and therefore by definition general purpose tooling. So as an organization, we have a massive heritage, very proud heritage actually, of innovation and engineering as well as science to be able to build the tools that we need to perform the job that we need in a very efficient and effective way. In IT terms, that net is well, I won't say always, but often is not the right approach. Often you have to accept that whilst you could come up with some kind of self-homegrown Unix code container system, Docker's probably going to outperform you in the long run. Now, Docker might have some limitations, but that's what you need to learn to work with. So it's a real challenge culturally for the organization to adapt to abstraction, which is a fairly common concept in today's IT world.
And I wonder, the title CIO I used to think was a bit presumptuous, but actually, I'm coming more and more to the feeling that it's a good one, because actually what we're doing is actually looking after, as the CFO looks after the governance of finance, we're looking after the governance of, as you said, information.
Now, I personally wouldn't work for an organisation where technology wasn't at the top table. I'm much less concerned whether I'm called CIO, CDO of various flavours, CTO or anything else, because I think that's kind of not irrelevant by any means. It's an important clue to the approach that somebody's going to take to a job. But I do think it's no longer appropriate for very many organisations to have a technology function that is seen to report to CFO or COO, because I think it's indicative of an organisation that hasn't got it yet, to be honest. So that's a thing. So I really don't care about job titles. I do happen to carry the banner of CIO along with Director of Technology. And the next question is, what do we mean by technology? I've just had a very interesting talk with some people downstairs about this. Technology was easy to point at not very long ago. It's becoming increasingly difficult to point at. So I'm beginning to revert to a couple of definitions I like. One is by Douglas Adams, who defined technology as something that doesn't work yet. I quite like that one. And another one was, I forgot his first name, but was a computer scientist called Fry, who said technology can be defined as something that didn't exist when you were born. And people think I'm joking when I use those things to define technology, but I genuinely believe there is a role for somebody who has accountability in that kind of area. Because thinking it's about tin, thinking it's about data, thinking it's about software, none of those things are true. And I think I'm very passionate about the opportunity that organizations can generate by having somebody who kind of gets it, who gets and look, digital, DevOps, big data, all these things mean something. But in my view, it's all very much about looking through a particular window or a particular context at what fundamentally is the same thing. This is an unbelievable and explosive growth in the power of what technology can deliver and generate in terms of value.
Okay, well, really enjoyed our conversation, and it's been extremely illuminating. So thank you very much, and a personal interest to me as an old geophysicist, if you like.
Well, thank you. Bye. Thanks. Bye.